right, we are getting ready for quiz 2 in our growth and logarithm unit here. First question up the top. Identify the transformations. Remember, that's just a fancy word for shifts, but you've got to know the word. Okay, if you kind of remember, what does transformations mean? I'll be like, you need to be paying attention for the past week. From the original y equals log for the following graph. So in other words, what does this and this do to my graph? So I'll make mention here of my format again. Okay, the value inside the parentheses is my left and right, but it's the opposite of what I may think. So the plus 1 means we're going to be going left 1. And the minus 7 on the outside is my up-down, which in this case means we're going down 7. That's all I'm looking for. So then we kind of keep moving along. We're like, okay, rewrite the following into either logarithmic or exponential form. Now, it doesn't mean you get to choose. What it means is, if it's in a log, you're going to turn it exponential. And if it's an exponential, you turn it into a log. So basically, this is becoming this, and this is becoming this. But you may notice I twisted up one thing from what we did on the worksheet yesterday. I didn't make it checkable in the calculator. Okay? Did that for a reason. I want you to be able to actually have to think about this. So when we're doing these, okay, log, we always talk about this being my base value. So when we talk exponents, that would be my base. We've talked about how what's on the other side of the equals is my exponent, and how this 25 is my answer. Now, I had somebody first hour ask, couldn't I just think of it as base, answer, exponent, just take them in order? You absolutely could. That's where you kind of find that personal wheelhouse of yours that's going to work best for you. But that would be my format. And so then if I get the first one, I can sort of work it backwards to help me get this one. And here's what I mean. I can go, okay, so log, now let me start making comparisons. My base and my exponent was this little number. So there's the base of my exponent, so that's going to be the little number. And then I look and I'm like, okay, what was on the equals side? My answer was right next to the log. So what's on the equals side? The answer is right next to my log. And the exponent was over here. Base, exponent, answer. And I see the comparison and I get my values. Okay, but again, tomorrow you may have it all numbers where you can check. You may have it where it's not. So we've got to be ready for both. Okay, so if you've done your due diligence, that shouldn't be too bad. Okay, evaluating. Now let's be honest. I've shown you this two ways, and I know most of you aren't going to look at these and go 5 to what power is 1 and 6 to what power is 216. Even though you could play with the calculator a bit, because we're usually nice and they usually end up being whole numbers, so it won't be that big of a deal. But just in case, what we're going to do is we're going to take a peek using change a base. We're like, okay, I'll write it out here on the first couple, and then we'll just kind of roll them through. Change a base is when we do log of big divided by log of little, or log of my of value divided by the log of my base. The biggest thing I've got to remember, that I have to remember here is to close my parenthesis after my first log is completed. And get my answer. And that's the same thing on every single one of these. Don't make life difficult. Log big divided by log little. So those really should be the easiest points almost that you see on the quiz. And just kind of as a reminder, it's not about which number has the bigger value, it's about the physical size. Whoops, when we talk about big versus little. So 1/36 divided by log of 6. and I just keep working these. That I just did another example of what I'm talking about. Make sure you actually have to get the symbols in here, or the calculator doesn't know what I want to do. So I got to get my divide in there. That's better. And get my evaluating taken care of. Inverses. Inverses again. Switch the x and y. My job is I'm solving for y. Okay? I wish I could, but I can't just divide both sides by log base 10 because that's not what the inverse of taking a log is. The inverse is our big new mathematical word, exponentiating. Base word exponent. I'm going to use whatever this little number is, and if I happen to not see a little number down there, we assume it's 10 anyway. We exponentiate with that, because that's my inverse. That gets rid of my log base 10. And my answer, we've got to write carefully. It's 10 to the x powered. That's why we use the word exponentiate. It turns it into an exponent. If you write 10x, that's not right. Got to keep that up there as an exponent. And then as we hit these next two sections, that's what I was talking a little bit about before we started creating this video here. That will be the information that you have available to you via me when you're doing this quiz. I'm not going to tell you what they all mean, but it's going to kind of get your brain thinking, I'm hoping. So when I look at number 9, okay, we're expanding. First thing I'm looking for is there any quotients? Do I see any fractions? Well, I don't. Products. Now, you may not see this right away, so I'm going to rewrite this. So it's a little more obvious what's going on here. So I look and I go, okay, so actually there's little multiplication dots in there between the 7 and the A and the A and the M squared. So with that in mind, when I'm doing a product, and I see a couple of them, multiply turns into add. So I'm going to have log of 7. I see a little multiplication dot, that's plus. Log of A, see a multiplication dot, that's plus. Log of M squared. Once I've taken care of that step, my last one is power. Do I have any exponents? I do. Those exponents are coming back to the front. It doesn't mess with my first two terms where I don't have any exponents. And once I hit that third step, I know I'm done. So I'm not sitting there in wonder going, did I forget to do something? If I followed the order, I did not forget to do something, and I am pretty darn sure of it. Now 10, we're going to get a taste of all three. So 10, okay, expanding quotient. I do see a division bar here. So, log AB to the 5th. Divide becomes minus. And again, when we're expanding, every time we do a plus or a minus or anything like that, we write another log with it. So then I get to my step 2. Product. I have one product right here, A times B to the 5th. So that piece, log A, there's my multiplication dot, plus log B to the 5th, and we leave everything else alone. Yes, 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 yes. All right. So, what we're going to do now is I've only got one step left, and that's power. Any place I've got exponents, those are coming back down to the front. So I don't do anything to my log A. My 5 goes in front of my log B. My 4 goes in front of my log X. and I've knocked it out. And have that set. Okay, so expand, things get bigger. When we go to condense, it's just the opposite. And it doesn't matter whether it says log or natural log like this, the process is going to work the same way. So when we go to condense, power no longer means exponent first, it means I have a coefficient, and it's going to go back into an exponent. Now notice I didn't take the negative with my 5. So I'll leave my first one alone and move my 5 back up to the exponent on my B term. Then I just keep working my way down. Okay, condense, product. Don't have anything times A, don't have anything times B to the 5th. Nope. And I don't have a plus here either, which is what I'd be doing when I'm looking at condensing. Quotient, I see a minus here. That minus turns into divide. And also, condense means at the end we have one logarithm, or one natural log. So here I'm going to have my A, my minus becomes divide. We're down to one logarithm and we're condensed. Okay, so that's the process we're working through. This one, again, we're going to get several. Condense, power, any coefficient, which in this case is all 3 terms, is going to turn back into an exponent. Okay, so my first step's done, coefficients to exponents. Second, product. Do I see any plus? I do. So when I see the plus, that's going to turn into times. So log x to the 4th times y squared. Notice I'm condensing as I go. Minus the log of w to the 5th. And then I look again, and I go, okay, do I have any quotient? Do I have any minus that's going to become division? I do. So last one, so we're going to have one big old log, x to the 4th times y squared, minus is my division, w to the 5th. And I'm set. Take it piece by piece. Try to stay out of the temptation of trying to do multiple parts at a time. More often than not, it's just going to mess you up. And that kind of covers us for our condense and expand. So when we get to 13, now we're back to a question similar in 1. When looking at the function f of x equals 3 times 5/4 to the negative x power, is it growth or decay? Now, do I know what some of you are going to do here? I absolutely do. You're gonna kind of cut bait here, and you know you're going to get half right, but you probably also know you're going to get half no credit. Like, what do you mean? I should be able to answer this question without putting it in the calculator. Should. Now, you're like, but you're doing it anyway. I'm going to do it to prove a point. So I type it in. Hit graph. So I notice it's coming down as it goes to the right. So I'm like, okay, it's decay. I just visually saw that. Okay, is it growth or decay? Decay. Justify your answer. Justifying your answer is not, it went down to the right on my calculator. No. I'm not asking the calculator the question. I'm asking you. So how can you tell me if you didn't have a calculator why it's decay? You're like, the b value is 5/4. Well, let's look into that. 5/4. 5/4 is 1.25. That's greater than 1. That tells me it should be growth. There's part of my answer. Okay? Part of my answer is the negative exponent. Now, that's not all of my answer, because that would mean every time I saw a negative exponent, it meant there was decay, and that's not true. The negative exponent flips, or creates a reciprocal 5/4 to 4/5. And if b is 4/5, that's the definition of decay, because it's less than 1. You've got to get both pieces if you want full credit for this. The negative exponent's there, but that's not the only reason. What does the negative exponent do? Negative exponent causes a reciprocal. If you don't want to put in numbers, you can just use words. But you've got to get both of those parts to be able to get credit for that. Okay? And it can't just be based on the picture on your calculator. And then finally on this side, 14, again, going back towards number 1. If f of x is 5 to the x and g of x is 5 to the x plus 4 plus 3, explain how to obtain g of x from f of x. Translation. What is the transformation? What are the shifts? Similar to our log up top, whatever's in the exponent is my left or right. It's the opposite of what I think. So left 4. My up or down is what's on the end. Up 3. Okay. Really, the only thing I got to pay attention to is g of x. Everything else is just kind of there for me. Now, besides 13 with the explanation, the question that gets messed up most often on this particular quiz is as we flip over. Okay, 15 and 16. We are going to be graphing a growth decay, and we're graphing a log. And people get stuff mixed up on this. So I'm hoping by doing this today, we're going to clean that up. So before I hit graph on this momentarily, I have a question. Before I look, is this growth or decay? Decay. So I know before I ever hit the graph button what this should look like. It should be going down to the right. And there it goes. So I notice something else as well. I notice it's not hugging the x-axis like it normally does. There's a reason for that. What direction shifts does this plus 2 represent? Up. And that up 2 moved my asymptote up 2. So when I go to graph, me as the teacher, I'm going to be watching to see when you're putting your points in, are you getting sloppy and dropping it down here? Because that's not right. Now, am I going to check every single point you have to make sure everything's perfect? Probably not. But I am going to take note that your graph is going to get close to 2, but it's not going to go under it. Okay, I'm going to watch for that. When I go to do my domain and range, okay, these are the ones, and especially if I've made my graph right away, that I can see my domain forever to the right, forever to the left. And I can also see my range, my y values, from bottom, the asymptote tells me where the bottom's at, to top. Okay, there'll always be a connection. If there's an up or a down shift between that value and the start of your range. If there's no shift, it starts at 0. And once I have that value, now I'm ready to do my end behavior. And I've got to remember the connections between domain and range and end behavior. Okay, my domain values, my x values, go with the x portion of end behavior. So for this, I don't have to think very much. My range, my y values, tuck in here. Now this one I have to think about a little bit, but not too much. Because if I use this kind of as a guide, as x goes left towards negative infinity, so we're going left, is y getting closer to 2 or getting closer to infinity as I go up, 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 up? Closer to infinity. And I basically know now what this is, but I'm going to check anyway. As x goes to the right, my y value is getting closer and closer to the asymptote, which is at 2. Lots of things to connect if I've practiced and know where those connections are. Now 16 throws the loop in. Because 16 I look at, and there's still some stuff going on with my shifts in domain and range, but they're a little different. For instance, here, I have a shift of right 5. When I'm doing logs, a left or right shift is going to move my asymptote, because my asymptote here is vertical. That right 5 shift is not going to affect my range like it did on growth and decay. It's going to affect my domain. Ooh. And on this one, the range is the one that's infinite. Ooh. Now, if I don't know that right off the top of my head, am I doomed? No. But I have to understand when I go to graph this, if I decide I'm going to do that first, that I'm looking for something a little bit different. When I go to graph this, I've got to remember, this is not the whole graph because this does not stop here. It goes all the way down next to my asymptote. If I want to look at my points, okay, I look at that first error message. It's at 5. It's where my domain starts. It's where my asymptote is. And when I plot my other 2 points, I'm gonna use the calculator for right now, but I'm going to show you another way as well. Holy cow. 15, 1. Okay, we're way out here somewhere. Because some of you, and we've talked about this, there's an alternate option for graphing my points. If I look at my parent points, and maybe I even take my pencil real lightly, or if I'm using pen, I use it real light, and I plot real lightly 1, 0, and 10, 1. What I'm going to do is I'm going to take each of those 2 parent points, and I'm just going to shift them right 5. 1, 2, 3, 4, 5. There's my 6, 0. Here, 1, 2, 3, 4, 5. There's my 15, 1. They both get me to the same place. I don't care which way. They're both the right answer. We're good with that. But then I got one more thing I asked for this time. I didn't ask for end behavior. I asked for the x-intercept. Now, reminder, the x-intercept occurs when y equals 0. And it's a coordinate point. It's not x equals. It's not just a number. And I get fortunate this time. Because when I scroll up, I notice there's y equals 0. So I can just write it down. But let's just say it's not quite that simple tomorrow. Okay, what do I do if it's not in my chart? Well, here's what we got to do. We're going to have to do a little bit of math. So since I know y equals 0, I'm going to plug in 0 here for y. We talked about earlier, if I don't see a little number, a base number for my log, it's 10. And what I'm going to have to do is I'm going to have to solve for x. So, first job is I got to get the log out of there. We've already talked about this when we did the inverse. I got to exponentiate. Okay, get that log out of the way. 10 to the 0 power does not equal 0. If you type it on your calculator or anything else, anything to the 0 power is going to equal 1. And I look and I'm like, add 5x equals 6. I can calculate my x-intercept if it's not in my chart. So no guarantees tomorrow that you will have a chartless x-intercept or that you'll have one in the chart, but we're going to be ready for both. Just keep reminding yourself x-intercept y is 0. And finally, applications. Just like before, I give you the formula, use it. Scientist estimates the specimen begins with 450 bacteria if this specimen grows by 15% every minute. Write an equation that represents bacteria's growth. Then calculate how many minutes will pass before the population reaches 1,000. Okay, so things to discuss here. I know how many bacteria I started with. Got my A. 1. Am I going to be using plus or minus? Plus, because it's grows. 15%, remember, if percentages as decimals are not your friend, take the percent, divide by 100, that will tell you the decimal. There's my equation. When will the population reach 1,000? When is Y going to reach 1,000? So I type my equation. Oops, let me get it in here. Make sure it's to the x power and not times x. And I pull my chart. And what I do is I start from 0 and I start scrolling my way down until I see something that's more than 1,000 in the Y column. So at this point, you could just say year 6 if you wanted to, because that's the year it actually happened. Or if you want to be more specific, we know it happened in between here somewhere. So 5 to 6 minutes is fine. 6 minutes is fine. We round up if we're going to a single. I don't care. 18. We got to decide between 2 job offers. We did one like this yesterday with pi r squared and 815. Judison Industries has offered you a base salary of $30,000 with an $800 annual raise. There's the equation already for you. Warren Corporation has offered you a base salary of $25,000 with 4% annual raise. Already given to you. Which offer is best? Okay. So I got to put both of them in here. Don't lose your X. So double check, make sure you put the equations in correctly, because if we don't put them in correctly, we're not going to get the right answer. And I see there's going to be 2 questions. Which offer is best? Explain your reasoning. We'll chat about that. And then we've also got, how many years later will the salary from Warren Corporation exceed the salary from Judison? Okay, so I look at my chart. And we talked a little yesterday. Year 0 is where we're starting. So we start that Judison, you're making more money. So I'm going to scroll down until the Y2 column, the red column, is bigger. Maybe. There we go. So it looks like it's going to take 12 years for Warren Corporation's salary to be more. So, when you get asked the question, which offer is best, I would assume at this point that most of you are going to say Judison is, which is sensible. Okay, explain your reasoning. It could be anything as simple as better pay for 11 years. Okay, you can't just say because it makes more money. That doesn't make more money now, 50 years from now. When? I just need some more information. Or maybe you look at it and you say, well, hey, most people in their working lives are going to work 40 years. So if I think, I'm going to find a job and I'm staying there my whole career, not likely, but maybe, then maybe you could change it up and you could say, Warren, because 28 of 40 years is more. It depends on your outlook. Are you looking long-term or are you looking short-term? You got to make that decision, but I've got to have some number reasoning behind it. Okay? Either one works, though, with an explanation. And then finally here with 19, suppose we invest our birthday money in an account paying 6.5% interest compounded monthly. Use your calculator's table graphing function to determine how long it will take for your money to triple. Okay, here's the equation. Use it. Okay, you invest your birthday money. They didn't tell me how much, and I want to be a little more realistic this time. I know I normally use $1,000. The last time I got $1,000 for my birthday was never. So I'm going to go with 100. That's a little closer. So you can use anything you want for your starting value when they don't give you one. So 1 plus, be careful on your rate. Okay, 6.5% is, I see it's a decimal, but it's not the decimal. Okay, that is the decimal I'm going to be using, 0.065. But now we get to the end value. Okay, end value. Find the magic word, compounded. And the word after it is going to be the magic end number. Monthly happens 12 times a year. So that's going to go in here and here. And we don't know what the time is because that's what I'm trying to figure out. How long is it going to take? But then the question becomes, how long is it going to take for my money to triple? So if I had 100, how long is it going to take before it's 300? And that is going to be what I'm dealing with. So I'm going to go to my y equals. I'm going to type in the right side. And again, watch for your decimals. Watch for closing parentheses. So many little things can happen if I'm not careful. Once I've double, maybe triple checked that I typed it in right, remember, my goal here is, when does y get to 300? So I start scrolling. And I'm scrolling. And I'm scrolling. There it is. If you're going with 1 year, which is fine, whatever year that occurred is fine. If you want to go with a range, 16 to 17 is fine. But that's what we're on the lookout for. So let me make a couple notes here. Okay, first, again, quiz itself, 19 questions. Secondly, I'm looking at my little timer here. My little timer says this review has taken about 32 minutes. So well within reason, especially when we're doing explanations and stuff, to get done in a class period, if you're ready. Now, if the only thing you've done the last 2 days is learn by osmosis, I'm going to copy what he says like a robot, okay? That's not enough to have this quiz go well. You need to get some practice in on your own, whether it's grabbing another one of these and working through it on your own, whether it's finishing up yesterday's sheet if you didn't do some of those. If you practice, this is going to go well. If you don't, you're going to be kind of staring off and drawing me pictures and IDK and all that other good stuff. So put in your due diligence. This will go well. With that, we will be signing off.